do today, sir. I'll do it today.
Sure. Sure. So we have done with the vertical circular motion in yesterday's session.
Yes.
So let us try to do some problems better fastly. Okay. See the first question, beta. A block is released. A block is released from a height h from a height h on a smooth track. On a smooth track. Find minimum value of h. Find minimum value of h so that it completes the vertical circle. So that it completes the vertical circle. Block is somewhere like now here. This is your circle. And this is your ground. Okay. And here somewhere is your block. It is released from rest. U is equal to 0 and it has been coming in the downward direction. The height of this block from the ground is at a height of your h. Okay. And this is the radius of this one. This one is nothing but of your capital R. See the question, beta. A block is released from a height h. From here it is been released on a smooth track. That means there is no friction. Find the minimum value of h so that it completes the vertical circle. So it completes the vertical circle. That means it comes here right now and goes back to the vertical circle part of relation. So what is the given? Okay, na?
Yes, sir.
So when it is been dropping, what is happening? Can you tell me? When it is dropped from here to here, velocity taken by this body to reach from here to here is exactly similar as something like a body dropped. Yesterday I told you. So to reach this position right now, say for example B, and this one is of your height h. In the vertical circle, it is exactly equal to a body dropped. So when a body dropped condition, if I'm using v square minus u square is equals to 2a into your s.
Yes.
Initial velocity is 0, so v is equals to under root of your 2g into dropped from a height h.
Yes,
So velocity is equals to under root of your 2g into your h. And you know that what should be the minimum velocity of this block at your point B so that it will make a complete circular motion. What is that one, better? Under here, yeah. So to complete vertical circle, to complete the vertical circle, to complete the vertical circle, the velocity of block, the velocity of your block should be how much, beta? minimum at least under root of your 5g into your r. That
Yes.
means this v should be greater than or equal to under root of your 5g into your r. So this velocity, how much we got right now? Under root of your 2g into your h must be greater than under root
Root
of
over
your,
five.
greater than or equal to under root of your 5g into your r. So is there anything getting cancelled in this one? G and G will get cancelled. So it will be equal to your H must be greater than or equal to this root. This root also will get cancelled. So this will become how much for me? 5r divided by your 2.
2.
Okay. So minimum height will be equal to H minimum must be equal to your 5r divided by 2. So this must be the minimum height from which it should be dropped so that it may complete the vertical circular motion. Is that clear, beta?
Yes.
Next one. A particle of mass m, a particle of mass m is released from top of a smooth hemisphere of radius capital R with the horizontal speed u. Calculate the angle with vertical where it loses contact with hemisphere. Okay, so particle
Yes,
of
sir.
mass m is being kept on in smooth hemisphere. That means this is your smooth hemisphere, beta, like this. Okay, and this is the radius of this one. Radius of this one is, say for example, capital R. A particle of mass m is being released from the top of your smooth hemisphere. That means on this top there is a block right now here. A particle of mass m is released from the top of a smooth hemisphere of radius capital R. Then radius వచ్చేసి capital R. Okay, with the horizontal with the speed u. That means you are given it for this one speed of your u. Calculate the angle with the vertical where it loses the contact. This block slowly comes here, somewhere here when it comes right now. Like say before
Particle
it is
speed and loop.
down, yeah, it is making an angle theta with the vertical.
Yes.
Now the speed of this position might be how much for me? V. అంతే కదా? That means it has been dropped by a height of your how much? ఇది దీని center అనుకుంటే it has been dropped by a height of your, from here if I am taking, this is been dropped by a height of your h. అవునా?
Yes, sir.
From here it is directly dropped and it will try to fall onto the ground. It is not taking the path on the circular
Yes, sir.
hemisphere, isn't it? So what is this angle theta part of relation? Before it is been dropping, now tell me what are the forces acting on this body? One is no doubt its weight is acting in the downward direction,
MG.
that is your mg, isn't it? If this is theta, obviously from alternate angles this one is also your theta. If you resolve
Yes.
it over the center, there is mg into your cos theta, and along in this direction it will be your mg into your sin theta,
Sin theta.
isn't it? So and normal acting on this body is equals to how much for me? N, isn't it? So what is the height? Can you tell me, beta? H will be equal to how much for me? Yesterday only I told you R will be common into 1 minus of your cos theta, isn't it? Now
Yes, sir.
velocity when it is coming to this position is V. So I can use the kinematic equation. So what is the kinematic equation right now here? V square is equals to U square plus of your 2G
2
into,
years.
so initial velocity is U square plus 2G into H value is nothing but equal to R into 1
Into 1
minus of
minus cos theta.
So this is your V square. And along the vertical condition, what are the forces right now? See, mg cos theta is acting in the downward direction. Minus of your n must be equal to m into v square by r, because it is moving on the circular path, isn't it? So what is the force responsible for a particle to move in circular path? Centripetal force. So net force must be equal to m into v square by r. When particle loses the contact with the surface, when particle loses contact, the moment it loses the contact, normal will become how much? 0. This is a condition for the particle to leave the contact. So when it is leaving the contact, means normal must be equal to your how much beta? 0. Normal must be equal to your 0 part of
Because
relation.
it's not in contact.
Yeah, because it is now not in contact, but this perpendicular component, whatever it is, this n will get 0 part of relation. Is it clear?
Yes, sir.
Isn't it? So velocity is how much we got right now? V is equals to your u square plus 2gr into 1 minus cos theta part of relation, isn't it? So from this one, I
Yes,
can simply right now, velocity will be equal to how much for me? Velocity will be equal to how much from this one? Gets cancelled. V square will be equal to how much? This one is, say, for example, equation number 1. And this is your equation number 2. And normally, if I'm taking 0 in this one, so this will become for me mg into your cos theta is equals to m into v square divided by r. Anything is getting cancelled in this one? Mass and mass get cancelled.
yes.
So velocity, how much you are getting right now? V square is equals to your
Rg
rg into your
cos
cos
theta.
theta. So this is your equation number 3. Now substitute 3 in 1. Substitute 3 in your 1. 1 already in the v square.
Yes, sir. V square value.
Square is equals to your u square plus this one is 2g into r into 1 minus of your cos
1
theta.
minus cos theta.
So this will be equal to
In
your
place of V
r
square.
into your cos theta is equals to u square plus 2g into r minus 2g into r into your cos theta.
Theta. Yes,
This
sir.
minus term, yeah, this minus term of your cos theta you take on this side. So this will become for me how much? This will become for
PGR
me
cos
2g
theta.
cos theta plus rg cos theta. So this will become for me
PGR cos.
3gr into your cos theta. That will be equal to your u square plus 2g into
2GR.
capital. So cos theta will be equal to your u square divided by your 3g into r plus of your
Plus
2 by 3.
2G.
Isn't
They'll
it?
get
So this
cancelled, no, sir. Yes, like
yeah.
yesterday.
So this GR 3GR will come here right now. GR will get cancelled here. That is the reason we're getting here 2 by 3.
2 by
That
3,
means
yes.
theta will be equal to your cos inverse of your, this one is u
U
square
square
divided by
divided
3g
by
into r plus of your
plus 2 by
2
3.
by 3. So this is the angle made by the vertical. Have you got it, beta?
Yes, sir. Sir.
Hmm? If initial velocity is 0, what is an angle, beta? In this one, if u is equals to 0, ఒకవేళ అడిగితే just keep a note and write it. If initial velocity is 0 అనుకుందాం, దీంట్లో u0 వేసుకుంటే this will become for me how much beta? Theta is equals to cos inverse of your 2 by 3.
2 by 3, yes.
Isn't it? And one more point. If your velocity u is greater than under root of your g into r, that means theta will be equal to how much beta? 0 degrees kada.
Yes, sir. Means I didn't get that.
The block leaves the track at the highest position itself, isn't it?
Okay,
So
get
the
that. Yes, sir.
block, because it is try to making the circular path kada, so it will try
Yes,
to
sir.
leave the contact here itself right now, isn't it?
Yes, sir.
So u is greater than under root of your g into r, that means theta is equals to 0. The body will leave the track at the highest point, highest point flying in which direction beta? Horizontal direction.
Yes, sir.
Flying horizontally without traveling distance on the track, without traveling distance on the track. అంతే కదా?
Yes, sir.
Isn't it? So I hope you got rough idea related to this one, how to do such type of questions, isn't it? That is about your vertical circular motion part of relation. Is it clear, Avita? Sure. ఇంకో క్వశ్చన్ తీసుకున్నాను. Same based on this one model. A particle of mass m, particle of mass m is released on a fixed smooth hemisphere, on a fixed smooth sphere of radius r, of radius capital R, at a position where the radius through the particle makes an angle alpha with the vertical. What is the angle made by radius vector? What is the angle made by radius through the particle when the particle loses contact, when the particle loses contact with the sphere, your sphere, and in the bracket you take cos alpha is equals to 3/4. I'll just give the diagram for you. See here, this is the diagram given for us. This is the center, this is the vertical. Already block is here, not at highest position. Okay, and here from here it is released, u is equals to 0. That means already with vertical it is making an angle of your alpha. Okay, there is a situation given for us. When it comes to somewhere at this position, okay, it is losing the contact. That means with the vertical now it is making a new angle. That angle is nothing but of your beta. Okay, this is the radius r. Now see the question once again. A particle of mass m is released on a fixed smooth sphere of radius r at a position where the radius through the particle makes an angle alpha with the vertical. Okay, na? Somewhere here it
Yes,
is
sir.
been with the vertical. What is the angle made by the radius through the particle when the particle loses the contact with the sphere? That means after traveling certain distance here, now here it is losing the contact. That means in this position somewhere there will be a normal. The forces acting on this body is nothing but weight of the body, that is nothing but of your mg. Again here if it is right now alpha, so this one is nothing but also your beta right now, because the total angle is beta.
Yes,
This
sir.
will be in this direction mg into your cos
Cos
beta.
theta,
Downward direction it will be equal to your mg
mg
into
into
your
sin beta.
sine of your beta. And the velocity is also here is how much for me, v, and this is your normal here. Now again, what is the height from where it has been dropped, and you already know it how to draw it right now, isn't it? So it is being dropped from this position na beta. So
Yes,
ఇది
sir.
దీని position unde right now initial ga it has been dropped to this position. So this will be equal to how
That
much?
is the
This is
height.
your height,
Yes.
isn't it? So actually the component whatever taking is, this is the radius vector kada. So from here to here this will become for me how much? Can you tell me? If this is your radius vector, this will become for me r into cos alpha na beta na. From here if I am taking, this will be your r into
Cos
your
beta.
cos alpha ఈ కండిషన్ నుంచి దీనిది ఇది రేడియస్ r,
Okay, okay.
isn't it?
Yes, sir.
From here to here if I am coming, this value will become for me
Down,
r
down. Yes,
into
sir.
cos
Cos
beta.
beta.
This is your or cos
Yes,
beta.
sir.
So height
Okay.
will become how much for me here? H is equals to r into your cos alpha minus of your
Minus r
r
into
into your
cos beta.
cos beta. So R will become for me how much? Common. So height will be your cos
cos
of your
alpha
alpha
minus
minus cos of your beta. Height
cos
వచ్చిందా
of
చూడు
beta.
ఒకసారి. ఇది R నాన్న. Initially this is the vertical component. Then vertical component ఎంత? R into your cos alpha. Initial గా. It is not exactly from center. Somewhere here only. ఇది ఇక్కడ నుంచి ఇక్కడ వరకు. So this one is your R into cos alpha because the block is somewhere here. And here when it comes here, this is your R into cos beta. So I need to calculate H kabatti R cos alpha minus R into cos beta. So H is equals to R into your cos alpha minus cos alpha cos of your beta. Now how do you calculate the velocity? Velocity calculate చేయడానికి formula తెలుసు కదా మనకు. V square is equals to your U square plus
square plus
2G into your H.
2gh.
Initial velocity is how much? 0. So that will be equal to your 2G into H will be equal to your R into this one is your cos alpha minus of your cos of your beta. The same way mg into your cos of your beta minus of your normal will be equal to m into v square
Square
divided
by
by r.
r.
Again, when particle loses contact, you know it. When particle
N is
when
0.
particle loses contact, that means n must be equal to how much for me? 0. That means I can write here mg into your cos beta must be equal to m into v square divided by r. This m and this m gets cancelled. So velocity,
Yes.
how much I'm getting right now? You see, v square is
Because
equal to this one is g into r into your cos of your
beta.
beta. So this is your equation number. This is equation number 1. I'll take this one. I'll take it as 2, and this one I'll take it as a 3. Again, substituting 3 in your 1. Substitute 3 in your 1. So ఎంత అవుతుంది చూడు ఇది. V square value, how much we got right now? V square value is this one. So this one is GR into your
Cos
cos
beta.
of beta is equals to, in the one, what is another relation we are getting? 2GR. So
2gr.
this one is your 2GR into this one is how
Cos
much for me?
alpha
2GR
minus
into cos alpha minus of your cos of your beta. Anything is getting cancelled, beta. GR and
gr
GR
gr.
gets cancelled. So cos beta is equals to 2 times of your cos alpha minus 2 times of your cos of your beta.
Beta.
Okay. So minus ni
Yes.
ikkada తీసుకొచ్చేసి, if you bring this minus here, this will become for
3
me 3
cos.
into your cos beta is equals to 2 into your
2
cos
into
alpha.
cos alpha.
So that is equals to 2 into cos alpha value is given anything in the problem, beta. Chudu. Cos alpha value is given as 3 by 4.
Yes, sir.
So cos alpha value is equals to your 3 divided by 4. So this will become
2
for me how
and
much? This one is 2 ones are, this one is 2 twos are, this one is
3
3
by
by
2.
2. So this one is 3 into cos beta. This 3 also get cancelled. So
Yes.
cos beta is equals to how much? 1
Cos
by
alpha by
2.
2.
So
Okay,
beta
cos
will
alpha.
be equal to how much? 60 degrees.
Yes.
So angle made by the vertical. That means where it is losing contact with the vertical, if it is making an angle of 60 degrees, it loses the contact with the given floor. Is it clear, beta?
Yes, sir.
So I hope you can do such type of equations easily.
Yes, sir.
కాలేజ్లో ఏం చేస్తున్నారు అన్న ఇప్పుడు?
Sir, ఇప్పుడు అంటే track 2 లో అయితే we are doing vertical circular motion questions, sir. Exercise 3 we started yesterday.
ఓకే.
And track 1 లో center of mass shifting problem చేసాం సార్, అంటే రిమూవింగ్ మాస్
ఓకే. ఓకే.
ఆ కాన్సెప్ట్ చేసాం సార్.
చలో. తీసుకుని కూర్చుంటా. 1 kg stone, a 1 kg stone at the end of 1 meter long, at the end of 1 meter long string is drilled in a vertical circle. is whirled in a vertical circle at a constant speed. At a constant speed of 4 meter per second. The tension in string is the tension in string is 6 Newton. Is 6 Newton. When the stone is at dash. Number 1, top of circle. Number 2, bottom of circle. Number 3, halfway down. And number 4, none. Chalo, try to see it.
So we have U and we have the tension of string.
Yeah. What is telling is 1 kg stone at the end of the 1 meter long string is rolled in a vertical circle at a constant speed of how much? 4 meter per second. The tension
Yes,
in
sir.
the string is 6 Newton. When the stone is it at the top of the circle? Is it at the bottom of the circle or halfway down or none of the given condition?
Sir, it needs to attain some speed, no, sir. So,
Yeah.
uh, way down,
How?
then only the string will have tension, no, sir. If it is in the top and bottom,
At
like
the,
in more.
at the top you see right now, or at the bottom if you see, if this is your string right now, when the bottom, if it is at the topmost position somewhere like this, the velocity of this one is in this direction. Where are the weights of this one, beta? Weight of the body is in the downward direction, mg,
Yes,
and tension is also acting in the downward direction.
yes,
Now tell me, when the particle is moving in the circular motion, what is the force for that one? So F must be equal to m into v square divided by your L, the
sir.
distance. So it is equals to mass is how much for me? 1. Velocity is 4 square divided by length is 1. This is how much you are getting? 16 Newton. And this should be the force in order
Yes,
to
sir.
make it into vertical circle, isn't it? Now at highest position, you see, at highest position, if I'm talking at the top of circle, at top of circle, so what will be the tension? Can you tell me, beta? What will be the tension right now here? What should be the tension condition? At highest position, tension must be lesser
It's
than this one.
yes, sir.
Because at highest position, tension is how much for me? It will slack. That means for a certain interval of a time, the tension acting in this one should be lesser than your applied force. And the
Yes,
tension
sir.
at the highest position is T plus of your mg is equals to m into v square divided by your L. So T value is given how much for me? 6. Plus this one is how much for me? How much for me? Mass
One
is
in
1. T value is 10. That is equals to this one is how much for me? 16.
one
Ante
in
kada?
16 by
Isn't
16.
it? So this one is 16. That means this is how much for me? 16
16
is
is
equals
equals
to
to 6.
m into v square by your L only kada.
Yes.
So this applied force. So the tension in the string is 6 Newton when the stone is at your top of the circle. If it is downmost position, then what happens? You see, it will be T minus of mg kada. So it will be lesser
Okay,
than
yes,
that.
sir.
It is
Will
not
be less,
possible.
yes.
Yeah, it should be at what position? Top of the
Top of
circle.
sir. Yes, sir.
Okay, na?
Yes, sir.
Okay.
Sir, so actually, in top of circle, velocity is 0 and tension is not equal to 0, right, sir?
Yeah, tension is
And
equals to 0 at highest position kada.
okay, okay, yes, sir.
T minimum is equals to 0. At lowest position, we will be getting maximum.
Okay, yes, sir.
Got it?
Yes, sir. So in the bottom, it is tension is
Maximum.
yes, sir. So not equal to,
Yeah.
and V is equal to 0.
Yeah.
Okay, sir. Got it.
I'll give you one more problem. Is it? Time is also getting over for the recording. I'll try to rejoin it. Just take this one and try to do the problem till the time.
10 minutes is there, sir. 9 minutes it should.
A body crosses the topmost point of a vertical circle. Topmost point of a vertical circle with a critical speed. With a critical speed. Its centripetal acceleration. Its centripetal acceleration when the string is horizontal will be dash. First one is your 6G, second one is your 3G, third one is your 2G, and fourth one is G. चलो try check अंदर.
Means it's halfway. The string is halfway, right, sir? Sir. Sir.
వచ్చిందన్న.
Sir, we have to use that under root u square plus formula, sir.
What is asking? Yeah, centripetal
Acceleration.
acceleration formula you already know that.
Yes,
So what is centripetal acceleration? You tell me.
sir. Under root of
No. Centripetal acceleration.
v.
AC is equal
Okay.
to v square by your r, gada.
Yes, sir.
So in the vertical circular path of relation, it is making, isn't it? So when it is coming, body crosses the topmost point, until somewhere here it is in the topmost. Crosses the topmost point of the vertical circle with a critical velocity. Critical velocity means under root of g into L.
Okay, sir.
To complete the circle, gada, isn't
Yes,
it?
sir.
It's the
Sir, L
centripetal
is nothing but
acceleration of the
r, no,
string is
sir.
horizontal. That means when it comes to here right now, what
Yes,
is
sir.
the velocity? So centripetal acceleration is v square by r. How do you calculate the velocity? I told you at any angle, you already know the formula. Or else you can use the kinematic equation. What is that? V dash square or v square is equals to your u square plus
Square plus
2g into your L.
2gh.
This one is how much for me? GL gada.
Yes,
This
sir.
is GL. This is your 2g into your L. So this will be equal to how much for me? 3g into your
3gl.
L. So centripetal acceleration enta. AC is equals to, this one is how much for me? 3g into your L whole square divided by your R. R is nothing but equal to your L. అంతేనా ఇది v square కదా మొత్తం వచ్చింది మళ్ళీ స్క్వేర్ ఎందుకు వస్తున్నాను
Yes, sir. Plus
this is
3gl.
v square only na completely. So this one will be
Yes, sir.
3g into your L divided by your L. So this one will get
Yes.
cancelled. This will be equal to your
Okay,
3g.
3g.
What is the answer for that one? 3g.
Yes.
Got an idea?
Yes, sir. Sir, and that other acceleration formula is for any point, sir. That
No,
under root of
that another velocity, that is velocity at
that
any
is
angle theta. You
velocity.
can even use that formula, but no problem.
Okay,
If
sir.
you even use that formula, you will be getting the same answer.
Yes, sir.
Okay, now you can try it once if you need to do it out, no problem.
Yes, sir. But this is shorter method, no, sir.
Yeah, this will be the more shorter method so that it will be more convenient for you to do it out.
Okay, sir.
Okay, na?
Oh, yes, sir.
The same in this one only. If I ask you one more question, like say this is point one right now. Tension in the string, Japo. The tension in the string. The tension
T
in the
square
string
by R plus M
at the
equals.
lowest point or at the lowest position is how much? Come on. So when the body comes here right now, beta, this is the lowest position. Na? Weight of
Yes,
the
sir.
body is in the downward direction. Tension is in the upward direction. So how do you write the equation? You tell me. How do you write the equation? When it is
M
at lowest position, so this will be equal to how
T
much
minus.
beta? T minus, very good. T
Yes, sir.
minus
T
of your
minus M.
mg is
Yes.
equals to your m into your v naught
V.
square divided by your L. Hona kada?
Yes, sir.
So how much I'm getting that one, you see? Velocity at the lowest position will be equal to how much beta? For a particle to move in the circle, in the velocity, in the vertical circle, this will be under root
Zero,
of
sir.
your 5g into your L.
Okay, 5 years. Yes.
Ante kada?
Yes, sir.
So this will be T minus of your mg is equals to your m. V naught square will be equal to how much for me? 5g into L
5 GR.
divided by your L. EL వెళ్ళిపోతుంది మైనస్ ఇక్కడికి వచ్చేస్తుందా సో T will be equal to how much for me 6 times
6
of
M.
your mg.
MG.
ఓకేనా
Yes, sir.
so that are the conditions you need to do it. One more question you say.
Sir, L is
Then
nothing but R only, no, sir.
yeah, L is nothing but R on. How much time is there, beta?
Yes. Sir, 2 minutes.
Okay.
2
Can I
minutes.
stop and rejoin it, beta, once?
Okay, sir. Yes, sir.
No, beta.